Hello everyone, my name is Fan Yang. I'm the Technical Marketing Engineer for the Cisco CSR 1000V router. Today I'm going to talk about how does the CSR work as a high availability pair in Microsoft Azure, and how do you configure it to protect the public resource in the public cloud. So if you're taking a look at the topology on the right hand side, you will see this is a Microsoft Azure virtual network, and you will see two subnets inside of the, or three subnets inside of the virtual network. One is for the CSR subnet, and there are two subnets for the application subnet A and subnet B. And you will see there are two CSR working as a HA pair in the CSR subnet. So the CSR will have two interfaces. The first interface that will connect to the internet will be working as in the public subnet. There's another interface in a private subnet that will be working as the gateway for the application subnet A and subnet B. So the blue line is the active path. So the upper CSR or the CSR in the top will be the active CSR for all the application subnets. And in case of the CSR failed, the other CSR or the backup CSR will take over the place and will change the route table to make sure all the traffic will be redirected to the surviving CSR. So the second CSR or the backup CSR will take over the traffic. So that's how the HA works. So let's talk a little bit about the detail. So in Azure, since the GRE packet are not allowed, so how do those two CSR find out the status of each other? So between those two CSR, there will be a BFD session over GRE packet and over IPsec. Since the pure GRE is not will be dropped by the Azure network, so we encrypted the GRE tunnel with the IPsec encryption. So in that case, the CSR can find out the status of the other CSR or send like kind of the keep live packet through the BFD over GRE and over IPsec channel. Once the CSR detect the BFD failed, it knows the other CSR is done, and then it will make an API call to the Azure user-defined route API engine and change that route to make sure all the subnet behind the CSR or inside of the virtual network while using the surviving CSR as a default gateway or the active path. So that's how the HA works. Okay, let's talk about the demo setup we will present today. So on the right hand side, you will see there's a HA VNet, and in that HA VNet, the IP range will be 10.0.0.0/16, and there will be two subnets created in that VNet. One is the 10.0.0.0/24 for the public subnet, and 10.0.1.0/24 for the private subnet. In the public subnet, you will see there are two CSR, CSR active and CSR backup working as HA pair. And in the private subnet, you will see there is a virtual machine 10.0.1.4. There will be a CentOS virtual machine in that private subnet. And on the left-hand side, that will be another branch VNet, or you can think this will be your on-premise network or your corporate network. In that VNet, we will have two subnets as well, the public subnet and the private subnet. So the IP range for that VNet, for the branch VNet, will be 20.0.0/16, and the public subnet will sit in the 0.0/24, and private subnet will sit in 1.0/24. The CSR in that public subnet will establish two IPsec tunnel from the branch side to the HA VNet. So it will have first the tunnel from the branch CSR to the CSR active, and the second tunnel will be from branch CSR to the CSR backup. This is for the HA as well. And also on the branch VNet, there's a virtual machine 20.0.1.5 Linux virtual machine. So I will initiate the ping from the 1.5 or the 20.0.1.5 all the way to the virtual machine in the HA VNet. So that's 10.0.1.4. And I will reload the CSR active, and you will see the ping will stop for little period and then it will reverse. So which means the fallback has been made because the CSR backup will make the API call when it found the CSR active failed, and it will change the route table to point to the surviving CSR, which is the CSR backups interface, to use that interface as a gateway. And I will show how to configure the CSR working as HA mode. So the configuration will need two parts I highlight here. So the first step will be configure Microsoft Azure application, because you have to create an application to register that application, and the CSR can make out the API call and authenticate it. The second step is you go to the CSR, configure the CSR CLI or iOS XE CLI to let those two CSR working as a pair. Okay, so let's get into the demo. So first, I will log into those three CSR, and we will initiate the ping, so you can see the ping can work before we do the HA. Okay, now you can see this is the branch CSR on the left hand side, and this will be the HA CSR1, and there's a HA CSR2. So from the branch 1 CSR perspective, if you do a show IP route, you can see we can learn the routes we can learn the 10.0.1.0 from both of the CSR. They are coming from the two different tunnels. I will not include the tunnel configuration because it's just IPsec tunnel. It's very easy for configure. And then now let's go to the virtual machine. So I can log into the virtual machine from the CSR. So SSH. The IP will be 20.1.5. Okay, now I'm in the Azure virtual machine, branch virtual machine right now. And I can pin the 10.0.01.5. Sorry, 1.4 will be the Linux virtual machine. Okay, so the connectivity is there right away before we configure CSR working as the active and standby. So let's go to the Azure portal. So this is the portal I'm working on. As you can see, we'll have multiple virtual machine that's running. We'll have the 5 virtual machines as we showed on the topology. And if we take a look at the route table first. So this will be the CSR HA private route table. As you can see, I create this route like manually to use the 1.11 as the next hop. If you take a look here at the CSR1 show IP interface brief, you can see the 1.11 will be the CSR1's secondary interface or the private side IP. So I'm using the CSR1 as active right now before I configure the HA. So that's why the ping can work right now. Okay, so let's start to configure the HA. There is a configuration guide. So this is the beta version, but it has all requirement. So let's go through this guide to configure everything you need to make the HA work. So if you remember, the first step, we'll create the application, we'll do the authentication. So let's follow the guide to do that. So first step, we'll create a self-signed certificate. Since here has an example, so I will do it this way. Okay. And take that off. Okay, so I will open another terminal to do this. let's make a CSRHA. Okay. Just copy here. You can change anything name here. It doesn't have relationship. You can just change whatever name you want. Oops. Okay, so you will see there's a private key created, and there's an application certificate created as well. And now let's combine the public key and the private key. So this is the example. Let's make it bigger. Okay. Now you can see there's a full certificate created. Then we just continue and copy this command to examine the key, examine the certificate. So let's do it. Okay, you can see all the thumbprint or the key are printed out here. Okay, so let's save the public key. And how to save the public key? You find the full certificate key. If we do a ls, we can see the full certificate key. Let's do a vi, and you will see it will begin certificate and end the certificate, and copy that part. Okay, begin certificate is here, so we better go here to get all the part. Okay, so let's copy this part to the file editor here. Okay, text editor. Okay, let's copy it here. Now let's go back to the deployment guide, and then we will generate the certificate thumbprint. And we copy this. It will take some of the input, the full certificate PAM as the input, and it will generate a random string. So let's go here and do that. Okay, now you can see there's a string generated. Let's copy this part as well, because we'll use that part in the future. So I'll put here. Okay, and there's a link. Why do you have to do this? You can read the link to understand why we have to do this type of certification, because this is required by Azure. So let's go to the place and create the application. Also, it says you can create in class portal, because Azure offers you the class portal or the ARM portal, the Azure Resource Management portal. So I would like to do it in the ARM portal. So, but it will be the same. Let's go to the ARM portal. If you go to the Active Directory, you can see the application registrations, and there's the one I created before. It doesn't have a relationship to this demo, so let's create another one. We call it CSRHA test, and this is the web app, and the link you just put anyone. So let's put cisco.com. Don't have to do anything with the link. Okay, you have to put the HTTP. Or HTTPS, it doesn't matter. This is just to create the application. After the application has been created, okay, so after the application has been created, I just follow the steps here to make sure it has the right permission. So let's go to application, choose require permission, and this will just use this as a default permission. And we can just use the default permission if we check it, sign in and read user profile, and the one we need is only sign in and read user profile. So you don't have to make any changes to your permissions. Okay, now we finished the add permission steps. Now let's get the thumbprint. Already got this thumbprint before. If you can see, it's stored here. Okay, we need to configure the key credentials. So key credentials are used by the application to authenticate with your Azure Active Directory. And after the authentication has been successfully made, the application can make the API call. In order for you to update the key credentials, you have to update the manifest. So we need a couple of information. You need customer key identifier, so that's your thumbprint we just generate or get from the previous step. And you need a key ID, which will be your tenant ID. I will show you how to get a tenant ID in Azure Portal. And also the certificate value you just get from the previous step as well. So let's go to the Azure Portal. We click the question mark on the right up area and we click Show Diagnostics. Now you search for the tenant. So this ID will be your tenant ID. I already put those information together, so let's check it out. Close this window, go back to my text edit. This is my information. So you will use a custom key identifier, so which is your thumbprint, the key ID will be your tenant ID, and also certificate value. Let's copy this part of information and click the application. We just create a CSR HA test. So you see there is a manifest button. Let's just click the button. It will give you edit area. You search for the key credentials and we just copy the part here. And now let's save it. Okay, so this means your manifest has been updated with the correct key credentials. Okay, so now we need to add the application under access control to the route table so the application can have the authority to change the route table. Click the route tables. Since the route table will not change, it will be the HA private route table because this is the route table used in the private subnet. And we click the access control and let's add another row like contributor. We just search CSR. We should see this application and we click select. Click OK. Now this application has the authorization or the privilege to change the route table. Okay, so it's done. We go back to the deployment guide and we have to create the application key for the API access. So let's go back to the Active Directory. We will have to find the application and we have to save the other information as well because it will be used in later. So let's just do it here. So the application ID will be used. So let's just, if we remember, we have a place to save all those stuffs. Application ID will be the ID listed here. Copy. Okay. And then it asks another key, so we'll just keep the keys, click the keys, and we put like the first key or whatever, which is 1 year, it will expire. So after 1 year, the API cannot be made because the key will be expired. If you want to use this for like multiple years, probably you can choose 2 years will never expire. The value, it will be displayed on save. So let me click save. Be careful, this is the only chance you can save this key, so I will just copy it. And here, the app key. It's here. Okay. Okay, so we got the key. Oh, the other part I think we also need is the subscription ID. So for that subscription ID, we can get that later. So we just continue the deployment guide. Okay, I think that's pretty much of what we need to configure on the portal to make the application authenticated and has the privilege. So as I mentioned before, we need to get the subscription ID. So there are multiple ways to do that. So if you click here, you see the subscription, and you need to find out which subscription you are using. And you can see there are 3 subscriptions I have. And if you click the virtual machine, actually it will be the subscription used for those CSR. So the CSR, HA CSR1, if I click the virtual machine, it will show up. This is the subscription ID I use in this CSR. So let me copy that and put here subscription and let's put it here. Okay, that's pretty much of the configuration we have done on the portal, and we have to go to the CSR to configure. So the deployment guide also have some group, walkthrough of the configuration you need to done on the CSR, but I'd just like to continue the configuration I already done. So let's go. I have created the configuration files CSR config and CSR2 config. So we can just copy that part. So this is the certificates we need to create on the CSR. So let's do this first. We go to, this is Azure CSR. We can make this small. We go to the CSR1. Here's the CSR2. So we'll do CSR1 first and do the other CSR later. So configure T, pull the configuration. So after the configuration has been done, you just put a quit here. It will exit, and you can type yes to save it. And we configure the HTTP because there will be REST API, so it's based on HTTP. We just copy those configuration. This is the IPsec tunnel. It was used to encrypt the GRE packet, right? Because Azure doesn't allow pure GRE; it will block. And for the interface, you have to remember this tunnel destination. This tunnel is used for the BFD. So this destination IP actually will be the other CSR's public IP. So how do you find the other CSR public IP? So we click the CSR2, click network interfaces. This is the public IP we need to put. So I didn't change that yet, so I have to change this one. Let's put the tunnel configuration as well. Okay, the tunnel is configured, and here is the the part you need to be careful, because we already copied some of the information from the previous steps, so we can just change that. The BFD peer, this is will be the tunnel interface on the other side. You can see this is 101.1. The other side is .2, but you can always change that. The route table, it will be the private route table you will change. So if we go to the route table, we click route table, it will change this HA private route table. So we have to copy that in here and put it in. The default gateway, this is will be the CSR interface you want to use as a gateway, because in case of the other CSR fail, it will change the default route pointing to this interface. So in this case, I will put the private interface for the Gigabit 2 interface IP. It's gonna be 10.0.1.11. So I will put here. And the application key, we already saved here. This is the application key. Application key. And the subscription ID. Okay, the application ID has been done, so we have to continue with the subscription ID. And the CSR1 application subscription ID and the application ID. It's here. Application ID. Do not mess up with those IDs, so be careful. Tenant ID. Tenant ID. Okay. Okay. Let's double confirm tenant ID 49, application ID 77, subscription ID 47, subscription ID 47, application key. Okay, so that's correct. And the resource group will be the resource group that's hosting all the CSR stuff. So if you click the resource group, it will lead up to here, and this is the one I use to install all the HA-CSR. If you click that, you can see the resource that's listed in this resource group. So let's go to here and change that. Okay, now we can copy this part of configuration to the to the CSR1. Okay, go to configuration, let's do a show run. Probably there are some leftover configuration I put before. Just want to make sure. Where is the redundancy? Okay, yeah. So this is it. And we have to do the same for the CSR2. So if you go to CSR2, we'll create the key as well. It's the same key. So let's put here. Create. And here we have to configure the IPsec crypto. And then we have to do the tunnel as well. Okay, so this is the 101.2, the other side is 101.1, and this will be the destination of the CSR1 public IP. So we click virtual machines to get the CSR1 public IP. Network interfaces. So this is the CSR1. So we just replace this at the here. And then we go back here. We have to change this again. So we can copy this part here. Because most of the application and subscription, that will be the same, except this peer, right? So we'll just change this IP address. So just change this. And default gateway, since this is the CSR2 IP address, so it will be the, if you could do a show IP interface brief, this will be this IP. Okay, 12 here. And let's put this configuration. Okay, brief. Let's copy the configuration. Okay, so basically the configuration on the CSR is not that complicated. You just configure the certificate that will be used by the CSR to authentication with the application server, and then make the API call, and just crypto map that will be used by the IPsec tunnels, and this tunnel will be used by the BFD, and the redundancy configuration that has all the subscription, application ID, that type of stuff. So if you do show IP interface brief, you can see the tunnel is up. If you do show BFD neighbor, you don't see neighbor, right? Because BFD has to work with type of the routing protocols. You can enable static route, or you can enable any of the routing protocols you want. So in this case, I will just put OSPF. It should be very easy. So since OSPF, I think it's already been enabled to connect to the CSR on the branch. So let's take a look. Yes, and I already put the BFD all the interfaces here. So what I need to do is go to the interface tunnel 1 and put the IP OSPF area. And here on the CSR, let's check the OSPF configuration. Okay, it also put BFD, and I just go to interface tunnel 1 and do a show IP OSPF. Yeah, okay. Now, if we go here, show BFD neighbors. Now you can see the neighbor is up. BFD neighbors. Okay, so the neighbor is up. And then we can do a show redundancy cloud provider. Now it's choose Azure 100. That's the node ID we put. Okay, you can see all the configurations is here. So let me copy this part. Okay, so on the CSR1, the BFD neighbor will be 101.2. On the CSR2, neighbor will be 101.1. So that's correct. And they are both using the BFD tunnel 1. There's some like information delay here, so it doesn't show up here. It will show up later. And it will have the resource group. That's the same. Tenant ID, application ID, the application key, the route table we pull, and the default gateway. So this is default gateway 1.11. That's the CSR1's second interface IP. And this is what we CSR2's second interface IP. So let me try to see that again. Okay, so sometimes there's possibility the tunnel is not showed up here. So how do you quick do that? We can copy this configuration first, and we can remove the redundancy to try. So we just copy this. No. Okay, and then we copy the whole configuration again. Then we will show. Okay, now you can show the tunnel is here. So make sure the CSR1 and CSR2 have the same information output. Okay, so now everything configuration has been done. Let's go back here and take a look. Yep, the BFD, the GRE, all the stuff has been done. Okay, I think all the configuration has been done on the CSR. So let's try go back to the branch CSR, and let's SSHL into the Linux we have user 20.0.1.5. Okay, that's pin 10.0.0.1.4. Okay, so the pin is still there. The configuration we have saved. Let's go. So let's put the pin here. And now let's go back here and take a look at the route table. Because the only thing you want to measure, or you can measure from Portal, is the route table change. So you can see now it's pointing to the 1.11. That's on the CSR1. So I will terminal monitor here on CSR2, and I will reload CSR1. And we will measure two things. One thing is how long this will change to 1.12. Second will be how long the pin will stop. So there you should be able to see some difference. So let's do a reload. Okay, it's reloading now, and you can see the pin still going. Let's just maximum those. Okay, it's still going because it's restarting now, and if we refresh here, you can see it's changed, right? But since it has been changed to 112, you can see the pin is paused. It's not continuous. It will take around like several seconds to be filled over. So that's because the route table change is very quick. But after the route table change, it will take 40 seconds or to 1 minute to be effective. So sometimes probably you will see more than like 40 seconds the route table change, and then you can see the packet will go through. So that's the difference probably you will see in your case. So now if we go back to the CSR, okay, CSR2, you can see the logs. It says the BFD session is done because it detects the CSR1 is down from the BFD neighbor because the tunnel is down. Also the neighbor is down. that's enabled BFD as well. And now it will make an API call to the Microsoft application server, that application we created. And then you can see the Cloud HA BFD status transit, and this is something output issue, but it should be Azure Node 100 event replace route successful. So which means from a CSR perspective, the route change API has been already made, and you can see the route has been changed, and also the ping is still continue to go through. I think this is what I want to show you today in this demo, and let's do a quick recap. So we have two VNet, and on the right hand side VNet we have two CSR working as a HA pair, and we have the other branch CSR on the left hand side. We have ping from the branch VNet to the HA VNet. After we configure all the configuration on the CSR and we reload the CSR active, the ping can still go through from the branch CSR to the other side. So that's demonstrate how the CSR HA worked. It will basically detect the CSR failure and make an API call to the Azure REST API server and change the route table. So that's how it works. And we also show you how to configure the CSR to working as HA pair. So first step, you have to create the Azure application in the Active Directory, and you have to do all the certificates, authentication stuff, and change the application manifest and give it the privilege to change the route table. And then you go to the CSR, you grab the subscription ID, application ID, all those information from the Azure, and you put the configuration on the CSR. Also, you have to build the tunnel between the CSR active and the CSR backup, so they know the status, or they can exchange the keep alive. And after one CSR failed, the other one will take over. So that's what I want to show you today, and thanks for your watching.